going to work on is we're going to work on what are called similar polygons. And the way that I like to start this unit out with these guys is since this is kind of what we're going to be doing pretty much the course of the rest of this chapter. So what we would like to do is try to do a very generic, basic setup to show how everything is always going to work. And I want to go back to chapter 4? Yeah, way back in chapter 4, we did congruent triangles. Remember that, congruent polygons? When you had, if we said, let me just write this out real quick. If I said that we have, for example, A, B, we'll just say it's a triangle, was congruent to triangle X, Y, Z. When you had that, what we call a congruency statement, you knew right away what angles matched up. You knew right away what sides matched up. Does that vaguely ring a bell? Yes? No? Maybe so? What angle has to be congruent to angle B? Y. What side length has to be congruent to YZ? BC. Okay? So we knew that within congruency statements, it told us what angles were congruent and what sides were congruent. What's different today is that we're not dealing with congruency, we're dealing with what's called similar. In essence, it's very close to what they do. But when you have similar polygons, and we're just going to use different letters real quick. We're going to go, instead of just going right into a triangle stuff, we're just going to use 4 letters for right now. So let's say we have polygon A, B, C, D. And there's a different symbol for similar. It's just the singular squiggly. All right. And then we'll say W, X, Y, Z. So when you have similar polygons, 2 things happen. First thing that happens is that all corresponding angles are congruent and all corresponding sides are proportional. Okay? So when you have similar figures, your angles will always be congruent, but the sides will always be proportional. Put away your phone, please. Okay? That's how this stuff is going to look. Now, I think we did this in first semester. Sam, I think you were the one that asked me about this. Remember when we talked about equilateral triangles? Equilateral triangles always have 60-degree angles, correct? And it does not matter how big the triangle is, they're always the same angles. Those triangles would always be similar to one another because they'd have the same congruent angles and their sides would have the same proportion between one to the other. And I think we talked about that real quick. I think it was you that asked me that question last semester. If not, just nod and smile.
It's also kind of like the pictures on the cell phone, speaking of the cell phone.
Yeah.
When you're looking at something on the cell phone, and then like an old person like me comes along and I have to do to make it bigger, right? I haven't changed it. It's the same picture.
Right.
The angle measures will be the same, just the side makes something.
Yep. Because as we get older.
Yeah, preview too.
I'm not there yet.
Oh, that's great.
I know, I'm sure. It'll be there eventually. So what happens then is that one of the things I want you guys to start, and Historic to attest to this, as we get into similar figures, similar polygons, similar triangles, and all that, every single thing boils down to the exact same problem. It boils down to what we call a similarity statement. If you know your similarity statement, you know what sides match with what. You know what angles match with what. It never changes. So all you have to be able to do is write out your similarity statement. If you could write that out, everything else falls into place. Here's what I mean by this similarity statement. I'm going to take these same letters real quick and put it on a clean sheet and show you what it's going to do. Now, do I even know what this figure looks like? Nope, but how many sides does it have? 4. That's all I know. So,
I need to know.
correct. So So I have this. That means I can do these two things. Oops.
Whoa.
Wrong button there. I know that angle A is congruent to angle.
Oh, that's when that's when we explained.
Mm-hmm.
We never done that.
No, don't worry. There are no proofs in second semester. It's okay. It's okay. I know it's a little. It's all right. We don't need an ambulance 2 days in a row. We go like 1 day without. Too soon, Gio?
Yes.
Okay. All right. So we know that those four angles, no matter what, are always going to be congruent to one another. It just says so because of what we call the similarity statement. Now, after that, this is where the side links, and this is where you're going to spend more of your time. When we're dealing with our side links, do you guys agree that there are four sides here?
Yes.
So what I like to do is this. I like to write out, let me ask, when you read textbooks, do you read from left to right or right to left?
Yes. Depending on the book.
Yes. Well, I'm going to go ahead and say that we normally read from left to right. So the reason why I'm doing this is that anything that I have on the left-hand side when I have a similarity statement, I'm going to use those letters for my numerator. Anything on the right-hand side, I'm going to use those letters for my denominator. I always keep that consistent. It's just kind of a standard way of doing it. So I'm going to write AB, BC, CD, and then AD. Those are my four side links. Those will be my four numerators. Proportions mean equal fractions. So I know that I'm going to have four equal fractions. And then I go through, bless you, and I'm going to go through and just rewrite my four side links of the other polygon. First two letters, WX, XY, YZ, and WZ. Notice how you keep the correspondence. If you keep that correspondence by going through the lettering like we have done in the past with congruency statements, it's the exact same thing with similarity, but there's fractions. That's it. So if you know certain bits and pieces of these things, gee, how do you solve proportions? Well, there's a lot of cross multiplying. That's how this stuff's going to work. But it all stems from being able to take this statement, knowing that you have similar figures, to write it out. If you can write out your similarity statement, then you do the math. Obviously, I'm not showing any math or anything like that yet. I'm just starting with the similarity statements. Okay? Nick? Yes, sir.
You ever keep some of these address and you write down on the person you like, you look at it, right? You pay attention. Man, you messed up.
No, I understand that because you want people to learn from mistakes, and I see that with my kids when they're doing their work stuff. Like, hey, and they're like, oh yeah.
Oh, so you let it happen now. You're not having.
No, it was funny. You bring that up. Moose, he was doing his math homework yesterday, and he was adding. They were adding like 3-digit numbers, 2-digit numbers, and 3-digit numbers. They were doing like three things with place value and all that stuff. And they had the problem on the worksheet, and he just rewrote the problem down. When the numbers were, and I think you guys have all seen this before too. I think he had like a 327, and then there was a 14, and then there was a 217 or something like that. When he was writing it down, he was writing 320, wrote 327, he looked up and wrote the 4, then he wrote the 14, then he did the 217. So he asked, as he was, from the worksheet, because he was looking up to write, you know how you guys look up to a page and you write down the wrong number because you look at the wrong part? So, and it happens all the time. And as a teacher, I know that, especially in math, I see it every day. And he added all this stuff up correctly, but then I was looking at the numbers like, dude, it's like, oh. And he was so upset. He said, but now I have to erase all of it. I'm like, it's okay. But you know what you're doing. It happens, man. I know exactly what you did. So, and you're right. You want them to learn. And I said, do you know why you did that? And he's like, you just went too fast. I'm like, I know you know how to do all this stuff. You obviously know how to do it. You just your mind got ahead of your handwriting. So it happens to everybody. It happens to Moose. It happens to you guys. So, right, and it's okay. Right? And you've seen that. How many times have you seen this, Ron?
All the time.
Yeah, and it's something you don't know how to math. You mathed it right. I mean, and I've told you guys have done that on tests and quizzes.
You guys,
I don't think you're wrong.
It always helps to take those few extra seconds before you do the math, check and make sure that you wrote down the right numbers. Because you have to go through all that work.
So, here's what I want to look at. What do we have here? What type of shapes are these? They're triangles. Now, well, let's just walk through this one together first, okay? Now, when we're looking at these two triangles, if I'm going from left to right, how do you want to name the triangle on the left? What letter do you want to use first? A. What letters do you want to go with? Triangle A, B, C. Now, what I want to do is I want to check to see, is it similar to triangle? What would have to be the corresponding letters for the other one? X, Y, Z. Good. Notice how they gave you tick marks, and you guys followed your tick marks. If I said B, A, C, what would I have to do for the other one? Y, X, Z. Correct. And that's the idea. You guys know how to follow your tick marks, which is good. So just follow tick marks and start to go. We're going to check and see, is this in fact similar to triangle? Well, we did A, B, C, so it's got to be X, Y, and Z. Well, first thing we do is check, do all of the angles match? We know that for certain because it's given to us with tick marks. So I don't have to write anything out. There's no numerical values. There's nothing like that to worry about. The other thing we have to check then is to see if all of the sides are proportional, which means we got to check to see if each one of their fractions are the same. So going in order of the letters, triangle on the left, what's my first side length? AB, I'm going to write it out first. I always write it out. My first side length is AB, then what? And then? All right, so what I'm doing is I'm writing out my letters first. I always, 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 always write my letters first. That way I'm less likely to screw something up. The corresponding letters to AB, BC, AC would be XY, YZ, X, Z. Again, this is something that each and every one of you guys have done. Following your letters to make sure the correspondence works. Okay? So, what did the value of AB equal? 15. So it goes 15, 20, 25. We okay with that for A, B, B, C, A, C? So I'm going to write those out real quick. So it's 15, 20, 25.
Yeah.
And now I go back to the other one. X, Y, Y, Z, X, 6, 8, 10. We okay with that?
Yeah.
All right. Now, in order for these two triangles to be similar, that means that each one of those sides has to have the exact same proportion. Okay? If they have the same ratio, so all the ratios have to be equal, which means that they are in fact proportional. I got my words mixed up there. So this is where the calculator comes in handy. All we need to do now, and now it's not the end of the world if you're checking a decimal. What I want to do is check, what is 15 divided by 6? What is 20 divided by 8? What is 25 divided by 10?
Using your fraction button.
Yeah, start using the fraction button. You want to see if all of those equal the same, then you know they're proportional. Because both things have to happen. You have to have all angles and all the sides with the same ratio. So as you go through that, we had what, 15 over 6? 15 over 6, you get 5 halves. Okay? So the first one is 5 halves. And then I check 20 over 8. 5 over 2.
Hey! I got 5.
And then the last one was 25 over 10.
Now, if all of these fractions were not the same, the triangles would not be similar. But because they are all the same, and that's actually called scale factor. Are we going to talk about that?
I don't think let's do it right off the bat.
Okay.
It might eventually by the end of the week. I think it gets a little bit later on those.
Okay.
And just the similarities first, I think. Okay? Do all three of those simplify to become the same fractions?
Yeah.
Yeah. That's why they're similar, just like Mrs. Sorrow was just saying.
Whoa.
What happens is, all you're doing is you're checking that the angles match. Once you know that the angles match, then you start writing out your statement. Writing everything out in letters, always, 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 and then fill in blanks. Okay? And that's how this stuff is going to go. It's not, was any of this mathing hard? No. And none of it was hard. Only thing you got to do is really come up with this. You know how to match angles. That's easy. You've been doing that forever. And then just writing down the different side lengths in order of the letters. Again, which is something that you guys have all done. Right? Excuse me.
Yeah, it took a while. I woke up thinking, oh, my
Not sure. But anyway.
I was like,
Oh. So, this is where the math then comes into play. Now, obviously, don't draw this out here, but I just want to show you that sometimes within the problems themselves, you're going to get information that you can substitute in. So it says in the diagram, Mn over Rs is equal to Np over St. Write out the proportions. I'm not worrying about the proportions for right now, but I want to solve for x. So they're telling you what has to work. So what's Mn in this case is 8. Rs is 10. Np is 4. And what do you get? You're saying it already. What is it? Oh, well, what is it? Ready? Error? See what we did there? Here.
Yeah, you did. You're right. I was slow. I was like, wait, I didn't go by twice. Oh my god.
It's okay. It's okay. It's okay. Again, they're giving you the information of how to write out and what to do with the fractions. We all know how to solve that problem. We did a ton of them yesterday. They're pretty easy. Okay? Try to remember where it gets a little bit crazier.
If you give me something, I can't.
All right. Again, don't draw this. All right? Don't draw this, but I want you guys to see what information they're asking, what we're talking about here. In this problem here, you have AB and BC. So AB was this portion here. BC was this guy. AE was this guy, and ED was this guy. So they have all those parts right away, don't you?
Yeah.
So if you know what the situation has to be, and you have the numbers, you just throw the numbers into the given information. Instead of them giving you the actual fraction equal fraction part, they're giving you in terms of the letters. You just have to figure out where the letters get the numbers. So what is AB equal to according to the diagram? What's BC? X. We'll just use X. Good. 6 over X. What's AE?
12.
12. And what's ED?
What's the example?
What's X? 2.
Oh my gosh! I had it was like that.
Cross both guys. What's 6 times 4?
Oh, like that.
So you get 12x equals 24. Divided by 12, you get 2. And it's okay. If you also notice that 6 times what is 12? What times 2 is 4? You can always go back and just cross multiply. That way you don't have to try and do it in your head. Yes. All right.
That was CD.
Well, we haven't gotten there yet. In order, if we need to know CD, we need to know this guy here.
Oh my god.
We'll get to it. We'll get to it. But gee, I wonder what's going to happen. It's going to be another proportion. You said equal to. You will get a scale factor as we go along. I'm sorry. What's that?
When he was, you go back.
Sorry.
When he was talking about like figure out like the other one, right? You just do 12.
No, because those are side lengths. Okay, those are going to be side lengths. There's really not a lot we can do yet. We can do some trig stuff, but we don't know some certain values to get some trig stuff. So here we are. In this one, notice what they're giving us to start with. AB, BC, AE, and ED. They're trying to find BC. Okay? You have to figure out what ED is. What are you going to do to figure out ED if you know the whole segment and one chunk of it is 18?
Then you just add the rest. What's 13 minus 18 left?
Yeah, just subtract it out.
That's what I.
So, the idea here is this goes back to segment addition, which we did, what, the third day of school, fourth day of school, something like that? So, it's still bringing back little bits and pieces from first semester without really bringing it back. But obviously, if the whole thing is 33 and this chunk is 18, how much is left for here? What do? You just subtract 12.
Wait, no. That's so wrong. I got 30, 15.
Okay. And once again, you're given your proportion to fill in the blanks. Once you're given the proportion to fill in the blanks, it's very fast, as you guys can attest to what we've been working on. You get AB is 12, BC is our unknown, AE was our 18,
And then ED is 15.
and once again, you cross multiply. So when you cross multiply these two, you get 12 times 15. If I'm not mistaken, I think that's 180. What's X?
10.
Okay. Yes, sir. We can make this more difficult for you if you'd like.
Okay.
All right. Let's see if we can skip ahead here. Yo! So let's take a look at this. I want to do this again and check to see if the two figures are similar. First of all, how many sides are there in each one of them? 4, okay? So what we need to do is got to check our 4 angles. I'm going to go from left to right. What letter do you want to start with on the left? M? Okay. So if I start with M, which directions do you want to go? You have M, then what? J, K, L. You okay with that?
Yeah.
Those pictures are kind of a pain. So, I mean, if you want to draw it real quick, I probably should have printed that one, but you can. What would be the corresponding angle to M on the right?
W.
W. Okay. So let me move this just a bit so I have a little bit of room. So we're going to say M, J, K, L. We're checking to see, is it similar, put a question mark, to W, T, U, and V. Okay? So first of all, do the angles match? And that letter correspondence, do those angles match? Yeah, because that's how you guys came up with it. So M and W singles, J and T double, right angles, and 3. Those work. All right. Now, write out how many side lengths do we have to worry about? 4 of them, because there's 4 angles, which means there'd be sides. So we have to write out our possible side lengths on the left. Move this just a bit. We have go through the order: MJ, JK, KL, and then ML. All right. I start with the stuff on the left-hand side. I put that always in my numerator, and then I put all this correspondence for the right-hand side in the diameter, denominator. So WT, TU, UV, WV. All right. Now you have your similarity statement you want to check. All that's left is to fill in the blanks with all the numbers. Okay. So MJ was, we got what, 6, 12, 24, 24. And then it's what, 6?
16, 14.
Now, when you look at that, guys, do you have to do any computation with this?
No.
Because we know right away that they're not going to be the same ratios. What's 6 divided by 6?
1.
What's 12 divided by 6? Are those two equal? No, you can just go ahead and stop then and say, these are not going to be similar. They're not similar. Okay? Because the ratios don't work. Remember, in order for them to be similar, you have to have two things. All the angles match, and every side length has to have the same ratio. They have to be proportional. If one of them doesn't, the minute that happens, you're wrong. Okay? It's not going to work. I would say, bless you, I wouldn't say that you're wrong, but the problem just won't be similar. Okay? Does that make sense? Again, it goes back, write out the similarity statement. How many times we...
Yeah, and if you're gonna make a mistake, that's gonna be it. You're gonna be like, oh, I don't have to do that. You're just gonna write the numbers down, and you're gonna think something is similar, and you're gonna go through and do a whole, they're similar because, it's gonna be wrong. So take the extra time, you guys, take the extra time.
I can attest to this. Every year we go through these things, I'll ask you, did you write your similarity statement? And you'll say no. And I'll say, okay, write your similarity statement. That's how it all boils back down to that. Okay? I don't think we need another one of those. Those are easy. All right. So why don't you guys take a minute with this? They're giving you the similarity statement. Oops. They're giving you the similarity statement, and they want you to figure out what X and Y are. So use the similarity statement of A, B, C, D is similar to E, F, G, D. Write it out, fill in the blanks, and solve for X and Y real quick. Take a couple minutes and try that one.
The first thing you're gonna do is write out that similarity statement, or write out your proportions for all your side units.
Yeah, mine are gonna be like.
The letters and then.
What? What's that? Program?
Man, you almost missed it.
Get out.
So there's a small trapezoid.
Oh, now.
You guys see it?
Yeah.
Small trapezoid big, so if you see the letters of the small trapezoid. Oh, because there's no numbers. Okay, but that's okay, so you're not gonna have that button that's gone, but the numbers that they give you. Don't take it out and say, you didn't call an X and Y. You have enough information in your other ratios to be able to solve the next. So it's okay, but you're not.
No, I think it just says solve for X and Y. Give me 1 sec.
I think I need to see.
The first thing you want to do is write out your sides, okay? So we know it's AB, BC, CD, AD. Are we okay with that? Okay, I try. Go again. EF, FG. All right. Fill in the blanks with your numerical values. We have 5, 7.5. Do I know what CD is? Do I know what GD is? No. Am I going to use that fraction? No. And that's okay. It's fine. You're going to see that a lot. Okay? Sometimes they'll get you more information than you need to. We might not know. What will happen eventually, though, is that you might know one of them, kind of like how we know one of these guys, and you've got to figure out the other one by doing a whole bunch of crossword. So it's okay that we're not using these two, because then I can just shift this one over a little bit. Okay? So now AD was what? 9? So now I go through the rest of them. EF was our Y. FG was our X. And ED was our 6. So here, let me just move this here then. I'm going to use that 9/6 to solve for X. And I'm going to reuse that 9/6 and solve for Y. I use it twice. Because they all have to be the same, so I know that 5Y has to equal 9/6. And 7.5 over X has to also equal 9/6. You reuse the one side length that you know both of for that fraction. And in this case, you can use 9/6, or can you simplify that?
No, yeah.
You can simplify that if you'd like, and just use, they would be what, 3 halves? If you want to do that, the math is a little bit smaller, but you guys are using calculators, so it shouldn't be that big of a deal. So you cross multiply here, you get what, 30 and 9, so let's see, 30 is 9y, divide that out by the 9, and you're going to get what, 10/3? Okay? So your y value is 10/3. Bless you. Same thing on the other one. On the other one, it would be easier to use the 9, or when you simplify 9/6 as 3 halves, because if you double 750, you get because this is the same thing as 3/2. Now remember, you don't have to simplify the fractions, guys. You have a calculator with a fraction bar. And all you have to do is cross multiply here, and it's gonna be okay. Alright? Now, like you guys were all freaking out. I know, she's trying to pawn it off on you. I get it. That's how she rolls. But it's okay. It's okay. It happens. You might not have every side. You're going to find the one that you have both parts for, and you're going to reuse that to find the rest. Okay? I think we only have like. So all I have. So on page 444. Please stop. So the first 3, it's basically asking you, are they similar? Which means I want you guys to write out the similarity statement and check all your ratios, make sure it works. And then on 18 and 20, I want you guys to try this. They're not giving you the similarity statement, but they're giving you the image. I want to see if you guys can figure out what has to match up with what via the image. Does that make sense? And so the positioning of the diagram, you might have to look through the tick marks to go through it. But try those 5 out. Shouldn't be too terrible. We're going to work tomorrow with more like those last 2 on the homework for tonight for 18 and 20. So if you don't get them completely perfect, I just really what we want to do is get you guys to try those 2. Then on tomorrow we'll continue with that style. Guys. And then on Thursday we'll bring it into to show how the triangles work. And then we work on that section for probably a good solid 3 days. Sometimes it's a little bit more depending upon how much of the algebra we have to go back recheck. So it shouldn't be so bad. Yeah, this I got a whole bunch of worksheets of it's basically just a lot of algebra, crossword algebra. Just make it easier because there's so much time. Definitely something.
I know, right?